So last, but certainly not least, we have Mike Salzberg. Mike is the business director for Biomaterials at Dupont, Industrial Biosciences, and he's held that position since 2005. He has over 24 years of experience at Dupont. Has a PhD in materials science and engineering. He started off in R&D. He's worked in strategic planning, business development, global product management, sales and marketing, and as a global business director. A number of different sectors also at Dupont: surfaces, electronic materials, titanium technologies, and industrial biosciences. So like the other panelists on today's talk, a tremendous amount of experience, and please help me in welcoming Mike to the podium.
Thank you, JF, and thanks everybody for the opportunity to talk to you a little bit about what we're doing with open innovation at Dupont. So what I'm going to do is give you a very quick overview of our strategy in the area of industrial biosciences, and then take you through 3 specific examples of where we've used open innovation to accelerate or enhance the programs that we've been working on. The first thing I think is important is to reintroduce Dupont to folks. Last year we completed a very important acquisition of the Danisco Corporation. And what that did is it sort of remade DuPont's portfolio in a way that surprises people a lot. So we're in 2011, about a $38 billion in sales company. And if you notice the top left there, agriculture, nutrition, and health are about a third of that. And in fact, the nutrition and health business and industrial biosciences are somewhat understated here because we only have 6 months of Danisco results in here. As you look forward to 2012 and beyond, ag and nutrition and industrial biosciences down there on the bottom are going to be an even more important part of DuPont's portfolio. So one important takeaway here is that ag and nutrition is a huge part of DuPont, $11 billion today. And also that if you look at some of the more traditional businesses, any of our businesses that are older, they call them performance. So performance chemicals, performance materials, performance coatings. But these are businesses that are the downstream markets for a lot of the feedstocks that we've all been talking about here the last few days. So for example, the performance materials business is where our engineering plastics and packaging resins businesses belong. They're very important parts of the DuPont portfolio. You can see they're $7 billion worth of sales there. They provide some of the downstream markets for DuPont. So today this is who DuPont is. Very much a biotech company today. More biotech patents than any other company in the world. Not so much a traditional chemical company anymore. And that's important to what our strategy is. So this business, industrial biosciences, was formed by combining the efforts that DuPont's had ongoing in what we used to call applied biosciences over the last 10 to 15 years. Developmental products, BioPDO, Sorona, as well as our biofuels and other materials efforts, together with the Genencor division of Danisco that we acquired earlier this year. When you put that together, you end up with a very strong business in industrial biotech. And in DuPont, that business plays a very important and central role. So these 3 circles sort of represent the DuPont strategy on one chart as a corporation. So again, we've been investing very heavily in ag and nutrition, starting way back with more than 10 years ago now with the acquisition of Pioneer Seeds and our traditional crop protection chemicals business. That's the foundation of our ag and nutrition business. So farmers and biomass supply chains, all that stuff's really important to us, an important part here on the left. And I mentioned advanced materials is the word that we use to describe our plastics businesses, our electronic materials businesses. These are businesses where DuPont is more and more moved away from commodity chemicals and much more towards high performance, value proposition driven kind of businesses. And industrial biosciences sits square in the middle of that. One of the really important roles that we're going to serve in the DuPont company is to make the bridge from petrochemical to renewably sourced by making that bridge from ag and nutrition to advanced materials. So if we look at what our business looks like, we take that industrial biosciences piece, we break it down into 3 business focus areas. The first one is what we call bioactives, which is a little bit of our use of a word that other people use for other things. Bioactives really means the enzyme business, peptides, proteins, sort of the traditional high margin, small volume businesses that are used for things like cleaning applications, personal care, household care, those kind of things. The traditional Genencor business, along with some of the pieces we had in DuPont that are enzymes and proteins and peptides. So catalytic amounts of a product that creates a lot of value in an end-use product. Biomaterials is the part I think most of us in this session are familiar with. DuPont had our BioPDO and Sorona business. The Genencor folks brought some of their activities in areas like bioisoprene. This is a huge area for DuPont, again, to make that bridge from ag and nutrition, the ag-based, biomass-based supply chains, over to the end-use markets and advanced materials. And then finally, what we call biorefineries includes both today an enzyme business that we have that sells into the folks like ADM or Cargill or whatever that are transforming things like, let's say, cornstarch into high fructose corn syrup. The traditional biorefineries. We have a very large business selling enzymes into those applications. But we also use biorefineries to refer to how can we take large volumes of biomass and turn it into commodity products like fuel. So biorefineries will have ethanol and biobutanol as well as our bioprocessing enzymes in those businesses. And these three areas are the areas that we're focused on in our strategy. So when you look at our open innovation examples I'm about to take you through, think about them in the context of these three things. So I'm going to be talking to you about some examples in bioactives and some examples in biomaterials, 2 in biomaterials and 1 in bioactives, that sort of show how we're using open innovation to advance our strategies. Again, and I think one thing I just maybe mention before we go off the slide is the core elements that tie all this together are really around renewable bio-based inputs, of course. Again, that biomass-based supply chain. What we call cell factories, you know, the idea of using the new tools of biotechnology. And also the idea, as a number of the other speakers have mentioned, we won't bring out a new product anymore that doesn't enhance the sustainability. So if we're replacing an older product or bringing a new product out, that new product's got to have better sustainability, better life cycle analysis, a lower footprint than the existing product that's coming out now. And that's really where we're coming from in all of our businesses. So those are the elements that tie together the strategy that we're about to talk about. Okay, so there's a lot of good reasons, and I think the speakers have done a great job of laying out why would you use open innovation. And certainly there's a lot of different reasons. The 3 reasons I'm going to give examples of here in this talk are listed here. The first one we've heard a lot about is access to complementary technology capabilities. So in DuPont, we're investing a huge amount of money and have for at least 20 years in developing these tools of industrial biotech, along with, frankly, the other complementary tools, the chemistry that goes with it, the material science and the engineering, all of which are required to make any of these really cool ideas actually become great businesses. So even with all that investment and all the capability that we certainly believe we have, we don't have a fraction of what's out there in terms of all the really smart people and all the great technology that's out there. So you'll see in industrial biosciences, essentially every project, certainly that I'm involved in, has at least one partnership to try to bring in other talented people and other great ideas to make our project go faster. Another important thing is market access. I mentioned we have good market access to a number of markets. You saw that wheel on that first chart. So for example, in certain parts of engineering plastics, we have great market access. But there's other places we don't have great market access. We don't have the application expertise. We don't have the ability to get downstream. So you saw how Lancet is helping BioAmber get downstream into the plasticizer business. Those kind of examples, getting downstream and really understanding what customers want and having the ability to do the application work and the formulation work is another important reason that we would use open innovation. We're in a lot of markets, we're not in all the markets. And I think finally, very importantly for us is that when we look at the universe of possibilities of what could be done with all this technology, we're investing a huge amount of money right now, but we can't do everything we'd like to do. And so one thing we'd like to be able to do is multiply our efforts through working with other people. We just can't do everything. And because we can't do everything, we like to find ways of finding options or alternative ways of getting to market by working with other companies. And I'll give you an example of one of those as well. So what I'll do now is just, for each one of these, take you through an example where DuPont is using open innovation to get for these 3 different reasons. So the first one is one maybe that people have been coming to this conference for a number of years, will have heard a lot about, which is of course the BioPDO and Sorona story with DuPont. So what I want to make sure we do is go back in time and talk a little bit about how do we actually get there. So, the development of the E. coli that is the centerpiece of the BioPDO production process was done with a lot of really smart people at DuPont working really hard for a really long time, but it absolutely wouldn't have been possible without a collaboration going all the way back to sort of the year 2000 time frame with some folks at Genencor, which of course at that time was a separate company. They had some access, they had some protein engineering, some metabolic engineering capabilities that we just didn't have. And so we set up a relationship with them where we could work together to develop this really groundbreaking approach to making BioPDO. And from Genencor's perspective, looking forward, they were a company that had a lot of expertise in what they call cell factories, but really no ability to look at the chemical markets or developing a monomer into a polymer and getting downstream. So for them, they said, wow, this is a neat opportunity for us as a company that has these great tools in metabolic engineering to look forward and work with a partner who can pull our technology forward, and we'll get royalties back for that. And from DuPont's perspective, we said, we just don't have all the science that we need to make this happen as fast as we'd like, so let's partner up together. And that actually worked out really well. The teams worked together beautifully, and together we were able to put together this amazing microbe that more than 50 genetic modifications to it that is today commercial in Loudon, Tennessee, and has been since 2006. So once the microbe was available, when we look forward to commercialization, the reality was in that time frame, 2004 to 2005, DuPont didn't have any fermentation businesses. We also had no real access to low-cost sugar. It wasn't something that DuPont did. As much as we're in the ag and nutrition business, we're selling inputs to farmers. Farmers are our customers. Seeds, crop protection chemicals. We were not people that had the expertise to know how can I get a hold of low-cost sugar? How can I run commercial fermentations at large scale? And so we partnered up with Tate and Lyle, who have turned out to be fantastic partners for us. They have all the expertise in the supply chain. Where do I get the corn from? How do I source all this stuff? How do I process it? But more than that, also brought to us the knowledge and the experience with large-scale fermentation processes. So from their perspective, they said, well, I can forward integrate from my expertise in creating glucose, corn sugar, and my supply chain expertise. I can leverage the investment that I've made as Tate and Lyle in the science of developing this fermentation and work together with DuPont to share that downstream value. And so in that case, the way the value was shared was through a joint venture because the assets are done. Loudon, Tennessee is a Tate and Lyle site. We're hooked up directly to one of their corn processing facilities. We were also able to leverage some of their expertise and things you don't always think about, like maintenance and operators can go back and forth between our plant and other fermentations and that kind of thing. So with that, the relationship with Tate and Lyle accelerated and de-risked our ability to take this really incredibly new-to-the-world technology, especially at that time, forward faster and with a lot less risk. So that's really what's happened with Tate and Lyle. And with that, you saw we started up a 100 million pound plant in October of 2006 and recently bumped that up to 130 million pounds. It's a business that's been successful for us, and it's really in great part because of the partnerships and the great folks that we work with in these two companies. All right, let me completely change gears and talk about a very different approach. Okay, so last year I came here and I talked a little bit about DuPont's omega-3s program. So most of you probably know long-chain omega-3s, EPA, and DHA. Today, the vast majority of that comes from fish that are harvested in the ocean. So 1 million tons approximately of fish oil is produced every year from about 30 million tons of wild fish that are caught out of the ocean. Well, the amount of fish that can be taken out of the ocean is capped by regulation and frankly by sustainability. And what's going on is both human applications and animal feed applications of omega-3s are growing very quickly. So last year I talked a little bit about the human nutrition applications. Well, we have a partnership we launched in September with our partner Aqua Chile, a new kind of salmon. And what do we mean by new kind of salmon? If you look at the use of fish oil, of that 1 million tons, only about 15 to 20% is used for human nutrition. All the rest goes to feed other animals. And the vast majority of that goes to feed salmon. Salmon need in their diet omega-3s to be healthy. And so today, if you look at the way that fish are traditionally farmed in Chile, in Norway, the way they grow salmon is it typically takes enough fish oil that it requires 4 kilograms of wild fish to make the fish oil required to grow 1 kilogram of salmon. 4 kilograms of wild fish to make 1 kilogram of farmed salmon. A lot of folks have problems with that from a sustainability perspective. So we saw immediately that our yeast, we have a Euroia yeast that's very rich in omega-3s, could be used as a feed ingredient, and by using that in lieu of fish oil in the salmon's diet, what we're able to do is to create a new category of salmon. So if you look at the bottom of this chart, we have a brand called Galasso. It's what we call harmoniously raised. And there's a number of different aspects of what makes it a better salmon. So the fish are raised in less crowded pens, no preventive antibiotics, no hormones, all that kind of stuff. But the really key linchpin here is that because of biotechnology and because we're able to find a non-marine based source of omega-3s, we're able to break this conundrum, we're able to break this constraint on the growth of salmon. Salmon's been growing 7 to 10% per year. Everybody wants it. It tastes great. It's a great source of omega-3s for our diet. But people were very concerned about how can we keep growing this if there's no more wild fish to give the omega-3s to the salmon. So